yeah, so from here you can download this machine. I have already downloaded this machine. Here it is, Metasploitable. Now I am going to power on this machine. This is basically an intentionally vulnerable machine that is designed for practice purposes.
Okay.
So we are going to perform a scanning and enumeration on this machine, as taking this machine as our target. Let it boot. Meanwhile, coming back to my terminal, in our previous session I showed you Nmap. Nmap is your network mapping tool. This is generally used to do port scanning. And when I say port scanning, here I'm referring to the logical ports, and I talked about logical and physical ports as well. The difference between the two. Okay. And probably I shared you some relevant learning resources as well.
Yes.
Right. So have you gone through those links?
Yes, I have.
Okay, cool. If you have any doubt, you can feel free to ask it from me.
Okay.
I did an if config, got my machine's IP address, starting an nmap -sn, followed by the IP address range. I need to do a ping sweep from IP addresses 192.168.136.0 to 255. Okay. Press enter. So this is just one way. Let me open a new window here. Is the font size. Let me show you another way. Nmap -smallest capital P 0 to 255. So both of these flags that you can see on the screen, the meaning of both of these flags are same. I'm just showing you just to aware you with the variety that we have here.
Okay.
That -sn is also used for ping sweep, and -sp is also used for ping sweep.
Okay.
Even the output is also the same.
Yes.
Right? So here I can see, I can figure out my Metasploitable machine's IP address. How can I figure it out? Let me tell you. 159.159 is my own IP address. .159 is here. So I need to discard this IP address. That's my own IP address. And as I'm using VMware, so .1, .2 and .254. These three IP addresses are standard in VMware, and they are reserved for VMware own interfaces.
Okay.
These three belongs to the VMware internal interfaces. So let's discard these three IP addresses. Now the only IP address that I'm left with is 192.168.136.151. Probably this is going to be the target IP address. Okay, I can confirm the same thing by going to Metasploitable. This is the machine. It's asking me for some login credentials. Let me type MSF admin. So MSF admin and MSF admin is your default credentials for Metasploitable machine. I have logged inside this machine. Do an if config. It's here. The IP address is 192.168.136.151. You can probably see it on the screen right here. Right? And we have already so this was just to confirm this thing, that we have figured it out the right way. So let's start with our scanning. Nmap hyphen smallest capital T followed by the target IP address, that is 151.
Okay.
We'll copy this IP address, paste it here, paste it here. So I have written two commands here. These are two variety of scans that can be performed. So what are these? On the left side, you can see hyphen smallest capital T. Do you know what it is?
I mean, you just did, right? SN and ST.
Yeah, those were the ping sweeps.
Yes.
We were not scanning open ports through that flag. Now I want to scan open ports on my target machine. Okay. So for that, we have got multiple types of scanning here. Multiple ways of scanning for open ports on my target machine. Okay. So one way is by performing. So now I'm going through the types of scans, type of port scans.
Okay.
So the first one is your TCP Connect Scan. On the left hand side, the flag that you see, hyphen smallest capital T. This is going to refer to as TCP Connect Scan. Press enter. Let it run in background. Let me go back to my this reference. So I hope you are already clear with the ping scan or ping sweep hyphen smallest capital P. It sends an ICMP echo request, and when an ICMP echo reply is sent back, it identifies that this machine is alive. Okay. Now let's come to the TCP Connect Scan. So what happens in TCP Connect Scan is a three-way handshake is completed. And that's how it is going to the attacker machine is going to identify that which all ports are open and which all ports are closed. Okay. So basically what my machine is going to do is my attacker machine is going to establish a three-way connection, three-way handshake on all the target ports. Okay. Wherever this connection is established, this three-way handshake completes. That's a SYN packet is sent, a SYNAC is received, and an ACK is sent. So the attacker machine gets to know that okay, so this port is open and it is listening for incoming connection. So this is how Nmap gets to know that the port is alive, the port is open, I would say. Okay. And then finally it terminates the connection using RST. As you can see in this diagram, a reset flag is sent at the end. So this is the underlying mechanism that is happening when I am doing a TCP Connect Scan. So let me go back to my Kali Linux, and here I can see the output. So the Nmap port scan outputs me the result in some kind of a 3-column fashion. Okay. So the first column is the port numbers, the second column is the state, and the third column is the service. The first column is self-explanatory, that is the port number that it has identified. It is 21, 22, 23, 25, 53. Okay, these are the ports. These are the port numbers. Then the state column. The state column can have options like open, closed, or filtered. Okay. Okay. When it says open, that simply means that the port is open. The closed means that port is closed. You cannot make a connection there. Okay. But what about the filtered? When it shows you filtered. So when the port scan outputs me the result, the state of a port as filtered, that simply means that maybe there is some kind of a firewall that is in place which is preventing us from making a connection. And another thing is that maybe Nmap is not 100% sure about the state of the target port. Nmap has not been successful in identifying the state of the target port, whether it is open or if there is some kind of a firewall allowing or denying what is there. Okay. Then comes your service column. So what is there in service column? So in service column, basically it tells us that what all service is running on that specific port. So these are your well-known services. Okay. And parallelly, let me give you a list of well-known ports. Maybe I shared it with you earlier as well. I don't remember.
The diagram you mean? I'm not sure.
So this is a non-exhaustive list of well-known ports. Okay. I shared this thing in the last session.
No, you didn't, but I have this.
You have it already. Okay, no problem. It's good to have this cheat sheet on the go, this reference sheet. Okay. Yeah. Anyways, so coming back to my port scanning. So on the right hand side on the service column, you can see what all services are running.
Yes.
Okay, cool. Now let me show you some different way of scanning. On the right hand side, I performed a SYN scan. You can see the different flag. This is your hyphen smallest capital S. So hyphen smallest capital S simply means a SYN scan. Okay. So the output is identical in both of these scenarios, right?
Yes.
So at the end of the day, these different types of scans are going to give us the same output, but the only thing that is going to vary is the way we are doing the scan. The scanning type or the scanning methodology is going to vary.
Okay.
Only the underlying function of both of these scans are different. The output is same. So now I'm going to explain you the underlying functions of different scan instead of showing you the same output of all these scans again and again. So let me go back to my Nmap sheet. Here it is. So I have explained you the TCP Connect Scan. Now let me explain you the SYN scan. Here it is. This is your SYN scan. It is known as SYN scan. It is also known as stealth scan. Let me write it here somewhere. Yeah, I have already written it here. Here it is. Stealth scan, and it is also known as half open scan. Okay. Also known as half open scan. So these are just your synonymous names for this SYN scan.
Right.
Okay, now what happens behind the scene is a SYN packet is sent to all the ports. Okay, and a SYNAC is received from those ports. Once a SYNAC is received, the attacker machine is able to identify that, okay, if I have received a SYNAC, then probably this port is open. And from this point, the attacker machine is not going to establish a connection. It is not going to do a complete three-way handshake. Instead, what it does is it sends a reset packet. Okay, instead of sending an acknowledgement packet for completing the three-way handshake, it sends a reset packet and resets the connection.
Okay.
Okay. Yeah.
Okay.
So this SYN scan is clear to you?
Yes.
The TCP Connect Scan is clear to you? I have already told you about different flags, right?
Yes.
Okay. Now there are various other types of scans as well, as you can see in this diagram.
Yes.
Okay. So one your fins or your finish scan, as you can say, fin scan. Okay. What happens? What is the flag for fin scan? This is the flag. All of these different types that you can see on the screen, these are your types of port scanning. Different ways of scanning the port. Okay. So the flag for performing a fin scan is -smallest capital F. -smallest capital F for performing a fin scan. And what packet is sent? A finished packet is sent on all the ports. That's all. That's how the attacker identifies that which port is open and which port is closed.
But
Okay.
how can they identify without any reply back?
Yeah, so for that, actually, these three scans, the fin scan, the null scan, and the Xmas scan. As you can see on the screen, the Xmas scan is -smallest capital X, the null scan is -smallest capital N, and the fin scan is -smallest capital F. Okay, so let me tell you what happens is there's an issue with the RFC, and probably the number is RFC 793 if I'm not wrong. Let me see, I must have mentioned it here. Yeah, here it is. RFC 793. Okay. So okay, the formatting has changed. Let me.
So there is an exploitation loophole.
Yeah, sorry, there's a
Exploit loophole in RFC as mentioned, I guess.
no, there's essentially a, I would say it's probably a misconfiguration in the implementation of this RFC. Okay. Yeah, RFC 793.
Okay.
Yeah. So there's some kind of a loophole, you can say, that that's there in the RFC 793, which is exploited by these different type of scan. So what happens is, if I send a fin packet, okay, and if I do not receive any response, then probably the Nmap is going to mark it as open or filtered.
Okay.
Okay, if I sent a fin packet and a reset packet is received back, that means the port is closed.
Okay.
Okay, and if I sent a fin packet and an ICMP unreachable error is received back, that means the port is probably in the filtered state.
Okay.
So now you know that how the Nmap knows that if a port is open or closed. If no reply is received, that means it's open. If reset is received, it's closed. If ICMP error is reached, it's probably filtered.
Okay.
Okay.
This is interesting.
Yeah, so I have mentioned this whole thing in very detail here in my notes. Okay, and I have taken this thing, I have probably copied this thing from the official Nmap guide itself. Okay, so I mentioned the Nmap guide link here. There is a dedicated Nmap book. You can go to nmap.org. This is the official website for Nmap. And Nmap now got root. Tell everyone network security scanner. Okay. Reference guide, download book. Click on book. Review. Translation. Chinese. No, exam data is what is the dictionary. Half of the content is available in the free online edition. Okay, no worries, probably the full book is also available. It was somewhere here itself. More. Okay, sec list, no. Probably the directory was nmap.org/book, and in here, yeah, here we have the index of that book. Okay. And here somewhere it is going to be mentioned the different types of scans as well. Here it is TCP fin scan, XMS scan. So all of these three scans falls in the same category. Why? Because all of these three scans exploit the same loophole in the RFC 793. And another catch for this thing is that these scans do not work against the Windows target. Okay, you cannot scan a Windows operating system using these scans. Why? Why so? Because Windows do not implement this RFC 793. Okay, Windows do not work as per this RFC 793. That's why they are not able to exploit this loophole in this RFC. I just saved the changes. Why does it keep on? Okay, so now you understand why it is able to scan, how it is able to scan. Okay, how did it know that the target port is open?
It's like
that was about your
configuring the system.
Right. It's tricking the system, right? Actually, what happens is the system get confused in a fin packet that if I do not have an established connection already, then why am I receiving a fin flag? Why is it happening? Okay, so if it sends a reset, that means that port is closed. That the port is very well clear that I am not going to entertain any packet. If the system gets confused, that simply means that port is open and listening. Okay, then comes your XMS scan here. So what happens in XMS scan is the flag is -smallest capital X. This is the flag that you are going to use to perform an XMS scan. What happens behind the scene is 3 flags are sent. These 3 flags are your alternative bits in the TCP header. The three flags are finish flag, urgent flag, and push flag. Okay. Now the point is that again we are trying to trick the system. here as well. So these three combinations together in a single packet does not make any sense. That a packet having the fin bit, an urgent bit, and push bit does not make any sense. It's a nonsense packet. Probably shall be discarded. Okay, no meaning can be derived out of it. Again, so we are just sending meaningless data to the system and seeing, we are understanding that how system reacts to that data.
Yes.
Okay, that's how we are able to identify if the port is open or closed.
Okay.
That was another way. Now comes your null scan. This is another way of tracking the system. So the flag is hyphen smallest capital N, and what happens here is no flag is sent. Okay. Only null values. So when I talk about null values, let me dissect the packet and show it to you.
Okay.
So this is how a packet looks from the inside. If I capture the packet and dissect it, open the packet in a sniffer or in a packet capture tool. So here on this blue highlighted, you can see the flags field here. Okay. And whenever a packet is sent, the bit corresponding to that flag, the value of that bit becomes 1.
Okay.
As this is the example of a SYN packet being sent.
Okay.
So the SYN bit, the corresponding bit to the SYN flag is now set. So 0 is for not set, 1 is for set. 0 means that this flag is not being sent. 1 means that this is the flag that is being sent. So here SYN flag is sent. Okay. So what happens is when I'm going to send fin, urge, and push. Okay. So you can see. Let me get my stylus. Just a second. Yeah. So what is going to happen in the a fin scan, a null scan? In a null scan, all these bits are going to be 0. It's going to be a 0.
Okay.
Nothing here. No SYN. Nothing here. Okay. So again, the system is going to be confused. But what kind of packet is it that no flags are set? Neither it is a SYN packet, nor it is a fin packet, nor it is a reset packet. Then what it is? Okay. And what happens when I send when I do an XMS scan? So in that case, let me change the color with fin flag. So the value is going to be 1 here, 1 here, the push flag 1 here, and the urgent flag 1 here.
Okay.
So these bits are going to be set as 1, and all the others are going to be 0. Now again the system is going to be confused at what am I getting here, what it is all about. So these are some of the different types of Nmap scans.
Okay.
So I hope the underlying methodology is also clear to you. Okay, how to use these flags. So the usage is very simple. Just like I showed you ST, the connect scan. Just I showed you the SYN scan. Similarly, you can use the corresponding flag to do the whatever is required way of scanning. Hyphen small SX for XMS scan, small s capital N for null scan, small s capital F for fin scan. So everything is clear up till this point.
Yes.
Okay. Okay, so probably I have covered all the different ways of scanning.
Okay.
Now let's proceed further. No, protocol scan is not going to be covered. Windows scan not, Mac scan not. I'll tell you version and the scan. Okay. So all the scanning that we were doing so far was we were scanning for the TCP ports.
जी.
So there are UDP ports as well in a system. So for that, the flags. So in the output as well, you can see in the ports column, all the ports are marked as /TCP. All of these ports are your TCP ports. Now let's say I want to look for what all UDP ports are open on my target system.
Okay.
Okay, so how do you perform a UDP scan? Okay, so for that, the command is nmap space hyphen smallest capital U. That is your for UDP scan. Followed by the target IP address.
Okay.
Press enter. It is going to take some time because UDP scans are very time consuming. They are difficult to detect the UDP ports. Why so? Because the underlying difference between the TCP and UDP protocol essentially, because there is no three-way handshake that is happening. No, we are able to identify these TCP ports because these ports give a fair amount of acknowledgement every time. Okay, either they are going to acknowledge or not, they are not going to acknowledge. But in UDP, as you know, the difference between the TCP and UDP does not have any functionality of acknowledgement, right? So let's see, only 6% is completed. It is going to take some time. Let it take some time.
Okay.
Meanwhile, I'll show you another scan. So the next scan is nmap space hyphen smallest capital V followed by the target IP address. So this is your version detection scan hyphen smallest capital V. Okay, the version detection scan. Press enter. So what it is going to tell us is it is going to tell us the exact version of the services that are running. Okay.
Okay. Service like system version.
The exact service that is running behind a port. That if an FTP is running, then what kind of FTP service has been enabled on the target system. Okay, so from here you can see another column has appeared with the name of version. So it says Pro FTPD 1.3.1 is running. This is the service that is providing you the FTP functionality on this machine. Okay. If an HTTP service is running, then what kind of server is enabled on the target system? So from here we got to know that Apache HTTPD 2.2.8 for Ubuntu, which is having PHP version 5.2.4 is running. Okay, so the HTTP server can be of any type, right? It can be a Tomcat server, it can be an Apache server, it can be a simple HTTP server created by a Python. Okay, it can be of various types. So to identify the exact version of the service that is running behind, we do a version detection scan. Okay, so you can see the difference between the output on the left side and the right hand side. Okay, left hand side just tells you that what all ports are open barely. Okay, but on the right hand side you get much more information pertaining to what all versions of those services are running. Okay, so that was about your version detection scan. Now let's start poking these services a step further. Okay, let's start with the enumeration part. So the UDP scan is still running. Let me see, 23% is completed. Let it run. Okay, so now, so I need to enumerate, or I would say I need to explore. I need to take more steps. Okay, I need to take a bit more deep dive into the target system. That if this service is running, that what next? Okay, so let's say port 80 is open here. Okay, port 80 is open. Let me try enumerating the port 80. HTTP Apache HTTPD 2.2.8.12. So the first thing that comes in my mind after seeing the port 80 is try opening this thing in the browser. Let me see what kind of website is hosted on the target system.
Okay.
Okay. So let me type Firefox. Start new session. Let's enter the target IP address here. The target IP address. Um, Copy it, paste it here. Okay, so a web page is actually hosted here, and the only thing that is written in that web page is it works. Okay, no fancy, nothing is being shown here. Only it says it works. Okay,
What does it mean?
it simply means that the server is running. Okay, and a web page is hosted here. The web page. So what happens is the whatever we are going to put into that index.html or whatever web page that is supposed to be loaded here, whatever HTML code we are going to put there, that is going to be shown to us here, right? So let me see the view page source. So this is the HTML code of the web page that is hosted.
Okay.
Okay. Just to verify that there's a web server that is running. That's all.
Okay.
Nothing more.
Okay.
Okay. There's an active web server that is running on port number 80. So as I'm making this connection on port number 80, that means it's an HTTP connection. Okay, let me try connecting this thing using HTTPS :// okay, probably remove this thing. Now I'm trying to connect on this on the target website on the port number 443 HTTPS. The standard port for HTTPS is 443, and from our scan results we can see that port number 443 is not open. HTTPS is not working.
Right.
Right, that's why nothing is shown here, unable to connect. Okay,
Okay.
so let's get back here. So now I'm going to show you how to do directory brute forcing.
Okay.
So what is directory brute forcing? So whenever you visit a website, okay, there are from the landing page, when you start exploring the website, it takes you in through multiple directories that are there. So let me take an example. Okay,
Okay.
else let me take an example of craw, probably craw.in. Entered it here. Okay, so now let me click on something. Let's try going somewhere. Click on services. Okay, let's go for. So when I clicked on services, you can see the URL being changed. So now it has moved into this services path, right? Now let me further try clicking something. Um, okay, so you can see here the path has changed now, right? So similarly, I can explore this whole website, okay, and sometime I can even go into. So this is going to be referred as a directory. So I'm currently in the IoT penetration testing directory of CRAW website, craw.in domain. Okay, so but in this case, I do not have anything to move forward from this point. I cannot click anything. I cannot go into somewhere. Nothing is available here, right? Probably there can be some directories that can exist here. Blah blah blah, blah 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 blah, blah 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 blah, something like this. Okay, that I do not know. It can be XYZ. So what I'm going to do now is I'm going to do a directory brute forcing now. Okay, let me copy this thing. So I'm going to brute force for the paths that can be available after this point. Let's go back to my terminal. UDP scan is still running. Let it run. Yeah, so for doing a directory brute force, the command is your DIRB. DIRB. DIRB stands for directory brute forcing, followed by the target URL. So when I say target URL, it needs to be a URL, http colon slash slash. This is how a standard URL looks like. Okay. Now press enter, and it is going to start with the directory brute forcing. You can see the directory brute forcing happening on the screen live. Okay. Okay, so our dub has completed and it gives us some output here. So in the output I can see various responses here. Okay, so I need to look for the codes, the URLs that is having code as 200. So 200 HTTP, these are your HTTP response codes. Okay. So there are variety of HTTP response codes. Let me show it to you. HTTP response codes. So 200 is the response code that is for OK. That means simply that the URL is working and that it's a valid URL and a reply is being received from the server.
Okay.
Your 300 series of code is for redirects, and your 400 series is for errors, client side errors, and your 500 series is for server side error. Let me see if I can get some good infographic here. So here you can see the 200 series is for success, 200 is for OK. The 300 series of HTTP response code is for redirection. The 400 series is for client side errors. Okay, 404 error is something that you would be used to seeing. 404 is for not found, for pages, for the URL paths that are not valid. Okay, then comes your 500 response code, that is your server side errors. Okay, so here in my output I need to look for the URLs that are having 200 as their HTTP response codes. The URL basically which have been successfully opened, which have this response code. So I can see index.html. So probably it's the same web page that we have currently seen, the it works web page. Still, let me try opening the index.html just to show you. Let me type index.html. The URL is same. Okay. Another URL it shows is php.info.php. Let me try opening it. php.info.php. Press enter, and it gives me the detailed information for PHP that is configured on the target system. Okay, all the detailed configuration. Let me look for something interesting now. So here it says a directory has been found. The directory name is Twiki. Okay, let's get back here. For the TWIKI Twiki. So Twiki directory is opening up and it is giving me some output here. I can probably explore further. Readme.txt, license.txt, Twiki documentation.html, Twiki history. Let's get started with this web. Okay, Click here. So basically, what I'm trying to do is I'm enumerating the port 80 further. Okay, so when I first opened URL, I was not aware of all these directories that could be present on the server. Okay,
Yes.
but when I performed the brute forcing, now I know that all these directories exist on the target system.
Okay.
Okay,
Mm.
Twiki bin view. Okay, a lot of things are being there here. Another directory is found. It says twiki/bin. Let me see. Twiki/bin forbidden. Okay, let's try moving into the bin directory here.
Mm.
Inside the bin directory, it has found /attach, /change, /edit, /manage, and all of them are probably having 200 response code. So
Mm.
try going to the attach directory, /attach. It works. It has opened, and basically it is providing me an interface to upload some file, which is attach a new file selected.
Mm.
Okay, so I can even probably upload some kind of malicious file from this point.
Yes.
Okay,
But they will be able to log, right? That you have access
sorry, they would be able
to see the access from your side. I mean,
right that so and so IP address has accessed our website at so and so time, and so IP address has uploaded so and so file this specific time.
right.
Yeah, they would be able to backtrack. But as we are doing all of this thing in our virtual environment, so the server itself is in running here in the VMware, right? So in this metasploitable machine. But in the live scenario, definitely there would be some kind of a system administrator. Okay, some kind of a SOC team is going to be there. Okay, nowadays enterprises, almost all of them, they have their dedicated SOC teams. Yeah, SOC teams, NOC teams. Okay, they are the whole task for a SOC team is to just identify, to monitor uh, the logs that are being generated, and to check for the any red flags that are being generated. Okay.
Okay.
Okay, let's proceed further. So now let me check my UDP scan. Is it over now? Yeah, it's done. So UDP scan has completed, and it even shows me the time that it took to complete the scan, 1071 seconds. Okay,
Okay.
and I can see some UDP ports that are open now. UDP, UDP, and UDP. Okay, but a lot of uncertainty is there in the UDP ports. Most of the times you are going to find open or filtered ports here that the Nmap has not been able to clearly identify the state of the port. Okay. So from my port scan, so is everything okay up till this point, right? You are able to follow along.
I'm able to follow.
Yeah. If things start getting over your head, or if they get overwhelming, you can let me know. Okay. Yeah, I'll stop at that moment.
Yes.
So now I'll be diving into the SMB enumeration. So I can see port number 139 and port number 445. These are your standard and well-known SMB ports. The NetBIOS port I can see here. The SMB services and servers are running here. Okay, cool. So how to check it? How to enumerate? So for that we have got this SMB map command. Okay, SMB map is used, and let's type hyphen hyphen help to open a brief help menu. So opening SMB map hyphen capital H, probably, I believe from my memory, hyphen H followed by the target control L. So SMB map is basically used to enumerate the SMB shares on the target system. Okay. So the syntax for using the SMB map command is SMB map hyphen H. Hyphen H is for providing the host IP address. I mean to say the target IP address on which you want to enumerate the SMB shares. So I have provided the target IP address here with an hyphen H capital H flag in the SMB map command. Press enter and let's see what kind of output can I see here. Okay, so the SMB map has successfully enumerated these SMB shares. So here I can see there's a print share, temp share, OPT share, IPC share, admin share. So your OPT, IPC, admin, print share, these are some of your default share that are there in almost every system if it is running an SMB service. Okay. So another utility for performing the similar kind of task is SMB client. SMB client, and I believe for that the flag is hyphen capital L. If I'm not wrong, let me check. Hyphen capital L followed by the target IP address. Press enter, and from the above, from this above command, we can see that there's a share, there's a temp share on which we can have a read write access. Okay. Other shares are of no use for us because we have no access for them. No access. The only interesting share is temp share. Okay. SMB client hyphen it is asking for root's password. I do not know any password. Let me type yada 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 enter. So I just entered anything random here. Okay. I did not knew the password. Just entered anything random and it says anonymous login successful. So anywhere if an anonymous login is allowed. So for anonymous logins, you do not need any credentials to log in. Okay. So it is also enumerating the shares. Along with it is providing me a little bit of more information here. Okay, slash temp says, oh no, it's some kind of a comment that is provided by the system administrator who has configured this thing. Okay. Okay, then work group, master, metasploit table. Okay. So these are just two different commands of enumerating the SMB shares. Okay. Now let's say if I want to move into an SMB share, I want to move inside the temp share. Let's see. SMB client, and it's probably this is the right syntax. Yada yada yada. Anonymous login successful. Try help to get a list of possible commands. Right. So here you can see that I have moved inside the SMB share. I have access to this share, and I have basically read write access to this share, right? So this is how you you access a share. Access is basically SMB share.
Okay.
Okay. So let me type help here. So you can see the terminal. My terminal has changed now, right? Because now I am inside the SMB share. I am inside the /temp share. Okay. Let me type help for getting a list of commands here. Okay. Question mark all info or blah 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 blah. Let me see if pwd works. Pwd, it tells me the current working directory. Here am I. Okay, let me do ls. It shows me what all directories are there. Let me try changing my directory. cd 5380.jsvc. Enter. Not a directory. Yeah, definitely it's not a directory. cd dot ice unix pwd. I have moved inside this directory. Let me do an ls. It's an empty directory. Let me do go one directory back. Pwd ls cd, move into another directory. Pwd, again it's an empty directory here as well. Okay, so I'm here. Let me try going one directory up. cd space dot dot. Let me see if I manage to go. No, I'm not able to go one directory upwards because I'm not allowed to go there. The only access that I have is in the temp share. I can do anything I want in the temp share itself. I cannot go any step above that. Okay, so I have a file over here. It's 5380.jsvc underscore up. Let's see. Let me type. So here I type the help command menu, and there will be two commands here. Probably get and put. Let me see where it is. Get, 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 get. Yes. No. Get. Is it even there? Yeah, here it is. Get, and here it is the put. Okay. So these are two. Get is used for downloading some file from the SMB share locally on your system, and put is to upload some file from your local machine to the SMB share. Okay. So let me try doing get now. Get 53 blah blah blah. Okay. X status access net opening remote file. Okay, so probably I am not allowed to download any file from here. Let me do an ls. Did I got it? No, no file was downloaded. Okay, so I'm not allowed to use the access denied. No, I'm not allowed to use that command. Anyways, so I did not found anything interesting here at this point. No problem. So the whole motive was just to show you how to enumerate stuff. Okay. A lot of times we are going to have some failed attempts that we are not going to find something interesting, but that is not the case. But that is not the point. The point is to look for something everywhere at every time. Okay. Okay, probably exit this thing, exit and clear it up. Okay, so far so good. So let's proceed further then. So you are clear with this thing. So I shall proceed further now.
Okay.
Okay, so let me show you some FTP enumeration then. So FTP port was also open, port number 21, where Pro FTPD 1.3.1 was running, you remember, right?
Yes.
Shall I show you the port scan?
Okay.
Port 21 is open, right? Okay, FTP followed by the target IP address is going to make an FTP connection on the target system.
Right.
Okay, it is asking me for my name. Let me type RKS here. Password required for RKS. I do not have any password. Just type anything here. Login incorrect. Login failed. Remote system by okay. Help. Okay, PWD. Please log in with user and password. Exit. So it was a failed attempt. Okay, now I'll try logging it with anonymous username.
Mm.
Password is anything I can type here.
Mm.
Remote system type is Unix. Login failed. So I was just checking if uh, login, anonymous FTP login is allowed. Because in case if anonymous FTP login is allowed, then I would have been able to log in to the FTP server using the anonymous as the username.
Okay.
Okay, by literally typing this thing, this string anonymous, if anonymous login is allowed. Anyways, so I had no luck, not able to log in. No problem. We do an exit. Again connect on FTP. Now I'll be logging in using MSF admin. The username and credentials that I am aware of.
Mm.
Okay. MSF admin and the password is same MSF admin.
Okay.
And now you can see the output. It says user MSF admin logged in.
Yes.
Okay, using binary remote transfer, remote system time is Unix. Let me type help as now I'm inside an FTP shell.
Mm.
Okay, bunch of commands here I can see. Okay, so let me do a pwd. I'm inside /home/msf admin directory. Let me try going one directory up, cd dot dot. Let me do pwd. I have successfully changed my directory. Nice. Let me try doing ls. Port command successful. And here I can run the ls command as well. I can see multiple directories here. Let me go back to the MSF admin directory for now. MSF admin. Let me do pwd and ls.
Mm.
So inside this MSF admin directory, I can see a directory named vulnerable. Let me try going inside it. Did ls, and I can see some more directories here. It's just Twiki 200 something, TikiWiki, Samba, MySQL. Okay, let me move to Twiki. Twiki 20030201.
Mm.
PWD did an ls, and here I have got another directory called Twiki source, and I have a zip file here.
Mm.
Okay, so the get and put command that I told you in the SMB share, those commands are valid in FTP shell as well. Okay, and they have the same meaning. The get is going to be used to download some file from here to locally on my system for my further inspection, and put throughput I can upload any file to this FTP server that is running. Okay, let me try downloading this .tar.gz. So get, let me copy the name, pasted it, press enter. it says port command successful. Transfer complete. Okay, let me check if anything has been downloaded now. Run ls, and I can see that the zip file has been downloaded now. Okay, let me quickly create a directory with the name of Twiki. Move this zip file into the directory. Cd Twiki. Try unzipping this file xvzf, and it has unzipped this file, and we can see probably that it's probably the source code of this application that has been installed on the target system. As I can see, /lib /pub/templates readme.txt index html documentation /bin. So we were able to enumerate this Twiki directory through derb, right? And when we enumerated the directory, we also found this bin directory there, /bin. Okay, let me go into this bin. Inside this bin, I showed you that /attach page, right? /bin. Let me do an ls. Here is a file that is attached. So actually, this is the file. So actually, I have the access to the source code of the target application. Okay, the application that is running on the target system. This is probably the source code of that application. I can go through the source code. ls-ls. Okay, attach. Let me try reading it. Cat attach. So I can probably go through the underlying source code of that application, and it's a Perl script /Perl. This language in which it is written, this is your Perl language. Okay. Okay. Okay, anyway, so this is how you enumerate the FTP port. Okay, and this is just a demo that I showed you. I can probably go through all the different directories that are available here. Okay, I can look through all the files. I can download something. I can upload something. I can go through the source code of the application. Okay, to have a very in-depth understanding of the target system that I'm trying to attack. Okay, I can do a source code review of this application here as well. Okay. Okay, so management.
So is it to say practice in my end as well, or should I just understand theoretically?
So you are asking that if you need to do the practical hands-on of all these things by yourself or not, right?
Yes.
Yeah, that's why I gave you that's why I gave you the link for that vulnerable machine, right? So as to you can also download it, set it up in your virtual machine, okay, and try all these stuff, try replicating all this stuff by your own, okay, try doing this stuff, and so, see, the point is that practice is going to be make you I would say, sound while using these commands. There are a lot of commands, a lot of flags that are there. Okay. Without the practice, you would not be able to achieve mastery on this thing. Okay. In spite of writing these commands day in day out, still there are some times that I forgot. I keep on losing my touch on these commands. Okay, that if the SMB map is having the -h flag, or is it having -l flag? I do not remember. Sometimes I get confused as well. Okay, so that can only be done using these commands again and again repeatedly. Repetition is the key. So you need to go through all of this thing. Okay, and so I showed you this different types of Nmap scan, version detection scan. Okay, I forgot about the OS detection scan. Let me tell you OS detection scan as well. Before that, let me just delete this directory. Cool, good enough. So Nmap capital O is the scan that is used to perform an OS detection scan. Oops, I need to paste the target IP address here. Where is it? Let me close this FTP connection for now. Here's the IP address. Copy it and paste it here. And what it is going to do is it is going to perform an OS detection scan. And in the output, at the end of this output, you can see, let me highlight it.
Okay.
Yeah. Oops. It says running Linux 2.6 point something, Linux kernel 2.6, OS details Linux 2.6.9 to somewhere between this version. So to identify the target OS, this is the flag that is used.
Okay.
So, okay.